Unit 8, Lesson 1, probability with and or not statements. And I added a little bit to this. What does it say?
Without a sample space.
Without a sample space. Okay, so what we're learning today, Trey, is for situations where drawing a sample space is not feasible. Okay, for example, if I'm rolling a 100-sided dice and spinning a 100-section spinner. Okay, would you like to make a 10,000 entry sample space? No. So counting up and or statements using 1,000 section or 10,000 entry sample space would take a long time, wouldn't it? So what we're learning today are the multiplication rule and addition rule that help us figure out and or statements when we do not have a sample space. Okay? That's why I start with the probability distribution, because probability distributions are fairly easy to figure out when you're talking about just a spinner or just a 5-sided die. So here we have, make a probability distribution for spinning a 4-section spinner, one shown, and rolling a 5-sided die. And I put times 2 because I want to make sure we make 2 tables. Right? Now, probability distributions, as you remember, are a list of the outcomes with the probabilities, right? Yeah. So, if I'm spinning the spinner, what's the probability I get A? 1/4, right? So, we put 1/4. Monica, does that make sense? Yeah. What about B? What's probability B? 1/4. C? 1/4. And D? 1/4. Good. Now for the dice, what's probability rolling 1?
1/5.
1/5. Good. Why 1/5, Aaron?
Because there's 5.
It's a 5-sided die.
It's 5-sided die and there's 1 face with it. Nice job. Okay, did a nice job. Okay, so all of these are 1/5. Okay? Those are all 1/5. Does that make sense?
Yes, sir.
Now if I add these all up, if I add all the 1/4 together, what will I get? 4 out of 4, which makes 1. If I add all these up, what will I get?
5.
Okay, so we know we did our probability distribution correctly when all the probabilities add up to 1. Any questions about that? No. Okay. Now, I know yesterday we made a sample space for this situation. Please, as we go through today, do not use your sample space from yesterday. Okay? Because what we're learning today is for when we don't have a sample space. Okay? Or when we haven't made a sample space. Okay? So don't cheat yourself and use that sample space. All right? Use the rules we're coming up with. Now, first thing we need to figure out is what does the word mutually exclusive mean? Does anyone think they know what mutually exclusive means or what mutually exclusive events are? Okay, mutually without. Okay. Exclusively means separate, right? Like if you're an exclusive means it takes it out, right? If you're an exclusive club, then you're separate from everybody else, right? Right? Like Trey's little club that he has behind his house in that little clubhouse, right? And Trey's exclusive man-only club, right? Like the He-Man Women Haters Club. You guys never seen Little Rascals? It's not in your club? Okay, extremely exclusive then. All right, exclusive is is separate, right? Right? Mutually kind of means together, right? Right? Like if we have mutual custody of this calculator, that means that John and I are going to share it, right? Right? So mutually exclusive kind of seems like a contradictory. Mutually can also mean at the same time, though, right? So what do you guys think mutually exclusive means? If I have 2 events that are mutually exclusive.
They're both exclusive.
Okay, let's think about an example. Here I have a dice, right? I roll my dice. What did I get, Josh?
1.
A 1. On that roll that I just had, could I get a 4?
No.
But I got a 1, right? Can I get a 4 too?
Yeah. No, you can't get that.
Not on that roll, right?
No.
So at the same time, I cannot get a 1 or a 4. So they're thought to be mutually exclusive, right? Because on one roll, I can't get a 1 and a 4. So rolling a 1 and rolling a 4 are considered mutually exclusive. Okay? Same idea if I have a deck of cards. Lovely deck of cards. Let's draw a card. Who wants to draw a card?
Me.
Me? Okay. Is that Ismail? Will be the first one?
Yeah.
Yeah? Okay. Ismail, draw a card. Just tell me what number you got. What card you got? before this we tells us, what's the probability that the card she has is both a heart and a club?
1 out of how many?
Both a heart and a club. Is that possible?
No.
What is the probability of both a king and a jack?
It's not possible. It's not possible.
It's not possible. It can only be one suit, and it can only be
One number.
one number, right? What'd you get? An 8 of diamonds. Okay. So it's not a heart or a club. It's not a king or a jack. But is it possible to draw a heart or a club?
Yeah.
Or a heart and a club? Sorry, heart and a club. No, not in the same draw, right? Is it possible to draw a king and jack?
No.
No. So drawing a heart and drawing a club are
Two mutually exclusive.
mutually exclusive. Okay? Drawing a 4 and drawing a 6 are
Mutually exclusive.
drawing a king and drawing a jack are
Mutually exclusive.
mutually exclusive, as long as we're using one draw. Okay? Now if I'm talking about consecutive draws, so if Ismail is going to draw twice, it's possible she draws a heart and a club, right?
Right.
If she draws twice, it's possible to draw a king and a jack. Right? But we're talking about one draw here. So, mutually exclusive events are events that cannot happen at the same time. Okay? They're events that cannot happen or cannot occur at the same time. Now I'm going to put in parentheses on the same, gentlemen, please stop, or ladies, whoever's banging your pencils. Okay. I'm going to put in parentheses on the same, colon, roll, draw, spin, etc. Okay. Because there are events that can happen on consecutive draws or spins or rolls that we'll talk about. Okay, when we're talking about mutually exclusive, we're saying they can't happen on the same draw, on the same roll, on the same spin. Does that make sense? Does that make sense, guys? Yeah? Okay. Any questions about that? No? Okay. Another question for us. If X and Y are mutually exclusive, then P of X and Y equals what? Think about that for a second. If X and Y are mutually exclusive events, then P of X and Y equals what? X and Y are mutually exclusive events, and P of X and Y equals what? Would you say, Jakai? 0. Why 0? Okay. 0 is the right answer, John?
2.
Nope. 0 is the right answer.
What's that?
Okay. Mark? What? Good. We can't get them at the same time. Mutually exclusive, gentlemen. Mutually exclusive means they cannot occur at the same time. Right? So probability of X and Y, when they arrive at X and Y, that means X and Y happen on the same roll, right? Yeah. Right? If X and Y are mutually exclusive, then there's no way I can get them on the same roll, or the same draw, or the same spin. So the probability of both them happening is 0. Okay, so if you know two events are mutually exclusive, the probability of them happening together are 0. Examples of mutually exclusive: rolling a 1 and 3 with one roll, right? Or drawing a club or heart with one draw. Right? Does that make sense, guys? Thank you. I was more excited about my club. Any questions about mutually exclusive events? Thank you. Anyone have an example they want to share with us? Mutually exclusive. Okay. The guy says if he has a purple shirt, no, it can't be white, right? So wearing a purple and a white shirt could be mutually exclusive, unless you're wearing two shirts.
Unless you got stripes on your white.
Two different shoes.
Maybe a striped shirt. If you
If
lack fashion sense, then you could wear two different shoes.
Yeah, so
Mismatched
that-
socks. Some people wear mismatched socks all the time.
Yeah.
It's tough with clothes, guys, because clothes aren't always definite.
Uh-huh.
Like you could say that probably I'm gonna wear shorts when it's snowing outside. Okay? But if I'm playing basketball inside, I'm probably gonna wear shorts, right? So clothing's a tough thing to do mutually exclusive with. Okay? Can you think of anything else that might be mutually exclusive?
Can we give us something?
Doug? Good. Getting heads and tails and flipping a quarter. That'd be mutually exclusive. What about being in math class and English class for the same hour?
Can have it.
Can?
Yeah. Because you could say, oh, I don't know how to
If
spell
you
this
had the
word.
split between the rooms.
But this is math class.
Yeah, but you're basically teaching us English.
No, I'm not.
Because sometimes you mess up.
I'm
on
not
the
teaching
word.
on spell word. All right. All right. Other examples, I was thinking of it snowing when the temperature's 100 degrees. Right? That'd be mutually exclusive, wouldn't it? I mean, it might happen in Michigan, because weird things have happened, but it's snowing when the temperature's 100 degrees. That could be mutually exclusive. Right? Maybe you can find some mutually exclusive ones this weekend and share them with your family and friends. They'll all appreciate that. No? Okay. All right. So, how is this going to help us? Two things with these two rules. We have the multiplication rule and the addition rule. All right? The multiplication rule is for and statements. Okay, so when I do not have a sample space and I want to find the probability of one event and another, then we use the multiplication rule. Okay, so this is for and statements. So maybe on your notes, you want to put behind multiplication, put in parentheses and. That might be a good idea. All right. Now for this, we're going to say x and y. We're going to assume x and y are independent events. What does independent events mean again? Okay, they're separate. What do you mean by they're separate? Okay, they're like rolling a dice and spinning a spinner, right? Jakai said they have nothing to do with each other. Does x affect y? No. Knowing x's outcome, does that affect the probability of y's outcome? No. No, that's what independent means, right? The outcome of one doesn't affect the other, right? So x and y are independent events, right? So the multiplication rule tells us the probability of x and y equals the probability of x times the probability of y. So the probability of x and y equals the probability of x times the probability of y. Probability of x and y equals the probability of x times the probability of y. You guys want to try an example? Not really? I appreciate the honesty, Trey.
Not really, but you're gonna do it.
Yeah, I'm going to do it anyways. I'm just being courteous, and I said, do you want to try an example? All right. So, example. Probability of rolling a 1 and spinning a, gotta make sure it's not what I'm using later. Okay, rolling a 1 and spinning a B. Okay. Looking at my tables that we just made, our probability distributions, do we know the probability of 1? What's the probability of 1? 1/5, right? So we do 1/5 times what, Matt? 1/4. Because the probability of spinning a B is 1/4, right? Now, if we remember how to multiply fractions, we multiply the top times the top, bottom times bottom. Good, so it's 1 out of 20. Okay. Does that seem easy enough?
Yes.
Yeah.
Okay, let's try this one then. Probability of A and B. Try that one. Know the answer. Do not shout it out. Let everybody give it a shot. Probability of A and B. Everybody take a turn at this. Do not shout out your answer.
times 4 would be 16.
Okay, probability of A and D. What'd you get, Josh?
1 out of 16.
1 out of 16. Okay. So how'd you do that? What's the probability of A?
It's 1 out of 4.
1 over 4. What's the probability of D?
1 over 4.
1 over 4. So then you did 1 times 1 and 4 times 4, and you got?
1 over 16.
Okay. If you did that, take your pencil and put a big X through it.
It's impossible.
Why is it impossible, Aaron?
Because you
you
can't
can't have
have
two
two at the
letters.
same time when they're on the same page.
Good. We can't spin A and D at the same time, right?
You can spin them
Right?
on 2 separate rows.
How are you going to do me like that, Mr.
A and D, I didn't, I just told you what mutually exclusive was, right? Okay. A and D are mutually exclusive, right? Right, guys? Yeah. So we can't do this. That's why it's important to know what mutually exclusive means. Okay? So A and D are mutually exclusive, so this equals 0 because they're mutually exclusive. Okay? Well, then we'd respin. And we're assuming that line is so infinitesimally small that's an impossible line to. It is too. Okay, let's try one more. Here you go, Josh. 3 and D. You can try that one. Okay. So try 3 and D. All right, probability of 3 and D. What's the probability of 3?
1 over 5.
1 over 5. What's the probability of D?
1 over 4.
Okay, good. The answer is 1 out of 20. Okay. Now, I know you're saying, is it always going to be 1 out of 20? And in this case, yes, because A, B, C, and D are all equally likely. 1, 2, 3, 4, 5 are all equally likely. When we get to more difficult problems where all the outcomes aren't equally as likely, let's say a spinner that has sections that aren't the same width, okay? Or we're not rolling dice, we're drawing cards out of a deck where certain things aren't equally as likely, then the probabilities won't always be the same. Okay, does that make sense? Okay, right now we're just kind of getting the feel for the rule. Any questions about multiplication rule? So if multiplication was for and, what are the conditions for? Or, good. Additions for the or statements. I'm going to draw a line right here so I don't get confused. Okay. Additions for the or statements. Once again, x and y are independent events. Okay. X and y are independent events again. Okay. Meaning they do not affect each other. The outcome of one doesn't affect the other. Yes, there's one for it. I don't know how it's relevant, but yes. Okay. So probability of x or y. What do I do here? What do you guys think? The multiplication rule we multiplied.
So you add. No, P, Y.
So we add.
No, P, X plus P, Y.
Okay, good. P of x plus P of y. Now, do you guys remember when we were counting sample spaces? We were counting boxes, right? If we did the probability of let's say to the probability of 3 or C. That means we count all of our, guys, we count all of our, yeah, go. Okay. If we were doing the probability of 3 or C and we had our sample space out, guys, we're doing 3 or C, we had our sample space out, we count all the 3's and whatever another, right? I said C's, but that's okay. We count all the 3's and all the C's, right? Now, what would we do with those numbers? We'd add them. That's why we have addition. Now, what would we have to be careful not to do? If I was counting all the 3's and counting all the C's, what do I have to be careful? Doug? Don't count 3C twice, right? Don't double count, right, Tony? I got to be sure I don't double count. Will this double count right here? Yes, this will double count. Okay? So 3C is 3 and C, right? So we got to subtract P of X and Y.
Okay.
All right? So we add the probability of X and the probability of Y, and then we subtract the probability of X and Y. Okay, does that make sense? And this right here, this part, gets rid of or eliminates double counting. Okay? Eliminates double counting. Right? Good thinking. Does that make sense? Sure? Yeah?
Can we do an example?
Yes, you will. Oh, and I can catch her the mutual exclusive again, will I? Okay. So the probability of 1 or, to make sure it's not what I'm doing later, 1 or A. Probability of 1 or A. Now what's the probability of 1? 1 out of 5. What's the probability of A? 1/4. If I do this, I'm going to get my double counting, aren't I? Right? So I got to subtract X and Y means what do I do with the 1/4 and 1/5? Times them, right? So here's the two probabilities. Here's the and. Okay, does that make sense? Yeah. Okay. Now, in order to add fractions, they have to all have the same denominator. It's called the common denominator, right? Right. So if I want to make a common denominator here, I probably should turn my denominator into 20, right? It's easy to figure out the common denominator. Multiply the 4 and the 5 together, and that'll always give you a common denominator. Okay? So if I multiply this by 4, we get 4 over 20, right? Multiply this by 5, we get 5 over 20. Multiply these together, and we get 1 over 20. So now we can just add or subtract along the top, right? 4 plus 5 is? Minus 1? 8. So we get 8 over 20, which reduces to 2/5. Now guess what? Your calculator doesn't need common denominators. So if you do 1 divide 5 plus 1 divide 4 minus 1/5 times 1/4, type it in just like this and hit enter, it'll give you that decimal, right? And if you do math frac, right, hit the math button, hit number 1 because it's fraction, then you'll get the fraction. So you can try that out if you want to. Okay. So you can use common denominators or you can just use your calculator. Either one works.
Where's frac at?
You hit the math button, and then frac is one of the choices. You gotta hit enter first. So type this in, hit enter, so you get a decimal, and then do math frac. Is it working? Yeah, 2 or 5. It work? Yeah. Okay. Let's try one more. So this is the probability of
Can't happen.
take it easy. Okay? Probability of 2 or 4. Probability of 2 or 4. You can't do and with those, right? What can we do or? Keep that in mind though as you use your equation. Josh, that can't happen part. Keep that in mind as you use your whole equation. Because where does the and come in?
After the order.
After you add them, right?
Yeah.
So you can add them still. You just can't. Just when you subtract, what are you subtracting?
0.
0. Figure it out? No? I'll try to find the probability of 2 and 4 and see what we can do from there, okay? Alright, so how are we doing?
Good.
What's the probability of 2? 1/5. What's the probability of 4? 1/5. Now,
I support.
oh, thank you. Goodness. Must be Friday. Okay. 2 and 4. That's not we can't do it, we just know it's what? It's mutually exclusive, so it equals what? 0. So 1/5 plus 1/5 minus 0. Because there's no double counting for 2 and 4. Right? No common denominators because they're already common. So 1/5 plus 1/5 is
2/5.
2/5. Make sense? Yeah? Alright. I'd like you to try the 7 that I have on either side of the board. They're the same on both sides of the board. Okay, yes, Doug.
Or probability of 2 or 4, can't you just count them?
You can do that too. But sometimes you might get an incomplete probability distribution. Okay? Or you might just get probabilities in a problem. Like they said, the probability of getting such and such thing is 5. The probability of getting the other thing, or 5 doesn't make sense. The probability of, let's say, drawing a club is 3/5. The probability of drawing a heart is 1/5. Those don't add to 5. So then we have to use the equation. Does that make sense? Okay. Any other questions? Anyone else?